Today's musings is about smart analytics, and it is titled as Rethinking QA through Smart Analytics. I'm sure we measure, we analyze, we collect a lot of metrics, and here the focus of the discussion or this musing is about what are some possible interesting ways to analyze data which seem a little more smarter, and what the meaning of smart I will elucidate as moving away from activities to outcomes. So most often we do find that we do collect a lot of metrics/measures which are related to a large degree to understand how are we doing in terms of activities, in terms of execution, and so on. Some examples, and not limited to these, how many test cases we ran, how many defects we logged, how many use cases we finished, what is our state of progress, where are we in terms of work, etc., etc. They're nice, they're important because as a person who's managing the project, those measures certainly help us know where we are with respect to where we should be. But they may not reflect true value to end users or external stakeholders. And that's what I want to muse about in the next few minutes. What I'm trying to look at is by analyzing smartly, or what I call smart analytics, we shift the lens from activities to outcomes, linking effort to insight and insight to business impact. And in this musings, I will only look at two sets of data, one related to defects and the other related to test cases. Okay, two sets of artifacts is what we're going to discuss. Not discuss, muse about. So without belaboring too much, I think some of the information measures that we look at for defects, which has of interest to us, is raw number of defects, number of open close, severity, distribution type, and so on and so forth. So these are in some sense giving you a sense of a basic characteristic of a defect as to what it is, what type of defect, what severity of defect, what status is it, and so on and so forth, so that one can make certain choices and continue to move forward. With respect to test cases, similarly, the measures of interest could be number, could be positives, negatives, sanity, automated, and so on. But this is only for what we have, and not all the test cases quite necessarily can always be considered to be documented, because we do discover quite a lot of things along the fly. But keeping the larger picture in mind, these are some of the information, some of the measures from which we derive some information related to test cases. Right? Now, these are in some related to the quote unquote the activities, characteristics which help us give some notion of how we are progressing, anything to do with respect to activity. So what is the meaning of measure of activities? What is the objective? It is to know the status. It is to understand certain characteristics. For example, how many are open, or how many test cases are there, what has been validated, and so on and so forth. Right? So it is quite necessary and important to have certain objective information related to the progress of work to help us make decisions of now what to do next. And therefore, we do collect certain objective information which are available as measures or metrics. Okay. And activities are fine. Any characteristics to help us make a judgment related activities are fine. But really the question is, what did they accomplish? What are the outcomes? Did it help me do better? Does it give a better value to the external stakeholders? Is there a better sense of outcome? So we know that activities are outcomes related. We perform activities, we produce outputs. And outputs that are useful and valuable is what we really look at, outcomes. So outcomes are more person, stakeholder centric. Outputs are more activity centric. So I prefer to use the word outcomes. Okay. And therefore, a measure of outcomes is useful to take actions to deliver value. Are we finding, for example, defects that really matter? how effective is, let's say, for example, early stage development test. Later, maybe, how comprehensive our test cases are. Are we confident that it is reasonably well covered, and so on and so forth, right? This is just to give you an example. It's not necessarily comprehensive. I only zoned in on defects and test cases, to do this discussion. And so when you're looking at it from an outcomes perspective and you're really focused not only on the activities, I tend to think that the analytics becomes smarter because we are more interested in seeing and benefiting from the activities, and certainly adjusting, improvising the activities to do hopefully something better. Better could mean improving the outcomes. It could be improving efficiencies of activities of doing, which could be doing it sometimes faster, could be doing lesser, and so on. Right? So those are various results of smart analytics. So let's now split this entire discussion into two parts, into what the smart analytics of defects could be. And the next part will take a look at the test cases. And I'll probably show you a small tool that we have developed, which is based on our methodology HiBIST, as a small 5-minute demo, which does exactly what I'm going to share. So what I've really taken is, I've taken in some sense the output of the tool, and that's what I'm using to illustrate what could be deemed as smart analytics. One part. So at the end of the day, we certainly, we do count the number of defects. We somehow think the more you find is better. We think more is better sometimes, and so on. But remember, quantity doesn't really indicate a whole lot, as we know from variety, not just limited to assurance. It is really the quality of any entity, in this case the defects, that matter. So it's not about saying more is better. It is really about, are we finding the ones that fundamentally matter? Are those defects that we found, are if they had been missed, would it have caused us a more grievous loss, right? And if I find a lot of issues and if I do not find the ones that matter, I'm sure you understand it's not as valuable. So I don't think I need to belabor that point anymore. And therefore, one of the ways to possibly find out or assess the quality of defects is, what kind of defects are we finding? What types of defects are we finding? Are we finding something very mundane and simplistic, possibly sometimes seemingly silly or careless? Or are we finding some interesting, sometimes maybe esoteric, but things that possibly have a higher value of risk that is harder to find? Right? Nonetheless, there could also be defects that are risky, which come into the system because you're fundamentally careless. So you might say, hey, it's seemingly a silly defect, but it causes grievous damage. That is true. But if it could have been found easily, and if you missed it, then it's an act of carelessness, which is in some sense unpardonable. But then on the other hand, if there are issues which are interesting, they have an interesting way to be uncovered, which means they are hidden, they're hiding fairly deeply, but they are important enough. It is not something so esoteric that it's going to occur once in a blue moon. And if you find it, for example, then we can say, hey, those types of defects are very valuable because they did save me a lot of risk. And then the real question is, it is nice to find defects and feel happy as a tester, but then they don't augur well for the engineering team as a whole, because at the end of the day, you still have to diagnose the defect, find out the problem, find out the causes, fix the problem, rerun, retest, and then redeploy. So bottom line, as a tester, I may be selfishness to be happy, but then I guess it causes unnecessary amount of rework and a wastage of money. So if it can be found at the right stage, or even preempted or prevented at an early stage, that would be absolutely welcome. right? So if I could get a better sense of what kind of issues I'm finding, and if I can really find the right ones at the right stage, then that would be far more smarter. Okay. So the thing that we're trying to think about is, if I put in a simple three-stage model where we say there is somebody who's constructing, there's somebody who's validating system, and there's somebody who's consuming the entire system, and then look at its three stakeholders of dev, QA, and user, and then we say there are different kinds of issues, right? So maybe as a developer, there are certain issues that I may find because I accidentally put them in. And let's say if I represent them with round circles, round dots, big dots. Consider that I found these as a developer. I did some tests, I wrote some code, I tested them, I found them, but some I didn't. So they escaped. Maybe some of them QA did find. And some of them they did not find, nor did we find, because QA's job is not to find these issues, right? And they continue to escape to customers. So which means there could be some issues that could have been caught at an earlier stage, which escaped into QA, which escaped into customer, and unfortunately, they require fix at a latest time. So it's the leakage. Remember here that as a QA, I am focused on finding slightly different kinds of issues which are more system oriented, and if these are represented by squares, maybe I find some, maybe I miss some, and maybe I'm missing some because I am doing certain tests which sounds like a developer test, and therefore I found some of these round ones, but that's not my job. And therefore, maybe I'm wasting certain QA capacity in looking also for issues that should have been found earlier, and therefore I'm missing some of these issues that I should be finding, and therefore that's a pain, right? So the idea here is to kind of think of it as, if it's a three-stage model, we want ideally the filter to be least leaky. If you can do that, that would be nice. You cannot guarantee that the filter is absolutely non-porous. There will be leak, but the question is it acceptable leak? So what do we mean by levels, and what do we mean by the stages? In our methodology called Hivest, we kind of look at it from 7 levels. What do you mean by levels? Quality levels. That means certain issues are certain levels. So I'm saying there could be a certain class of issues which are related to basic handling of data, which is an earlier stage. There could be some other kinds of issues which are related to deployment, migration, installation, configuration, which are higher level issues, which could be a level 8, and so on. So I'm just trying to map and say, look, L1 to L4. That means if a defect could be classified into L1 to L4, then maybe they belong to developer. That means, those issues should be found, and it's the developer's responsibility. So when I say developer, I mean a person who's constructing, right? And therefore, we are more optimal. That is the basis of smarter analytics in the context of defects. So if I were to say, hey, I've got some number of defects, don't bother reading this because it's just to illustrate a point. The question that I'm trying to ask is, if I have 24 some defects like this, what can I do to help to improve outcome? So the first thing that I do is to categorize. Previously, I used to do it in a human fashion. Now I have got a small AI-based tool which attempts to classify this because it understands Hivest, and therefore it tries to automatically classify or categorize the defects into quality levels. So it read this defect and then said, I think it is L1. And the second one, it said, I think it's also L1. And then it went on to a fourth defect, which is XYZ language labels. And then it said, I think it's a level 2, and so on and so forth, right? And then all I did was to say, okay, now that I've categorized them, let me now put them and then find out how many defects I found in what level. So now it seems to indicate that I've got about 3 issues which are at level 1. There's about 1 issue at level 2, and so on and so forth. So I'm basically doing analysis of how many defects are at every quality level. So what I've done is, instead of just looking at numbers, or instead of looking at severity and priority and all other stuff, in addition to all those, I'm looking at certain content related characteristics of the defect by reading the text. In this case, it's a bit of a automatic way of doing it using a tool, and then trying to find out if I can classify them into levels, so to speak. Right? And now I can infer from here there's approximately, I think I made a small typo here, mistake. It is 3 plus 1 is 4 plus 3 is 7, 7 plus 5 is 12. So 12 out of 24 issues really are development, which should be, I think, if I'm not mistaken, 12 plus 20, I think it's about more than 30%. So what it simply says is about 12 issues, or approximately somewhere in the 50% mark, is L1 to L4, which we, in the earlier slide, we understood where could be issues that probably ideally could be found by a fellow who is building the software. And the remaining, which is not 17, I think you have to subtract the 5, which should be 12, should be system issues, right? Now, what does it tell you? It seems to just indicate that, yes, we have found about 24 issues, approximately split half and half into L1 to L4 and L4 to L9. And what it is saying is it good enough? Are you doing the right job? Now, if you say, hey, this is what I, as a QA test guy, found in the last sprint, for example, then the question that I'm going to ask you is, you found 24 issues. I appreciate that. But do you know that you only found 50% of those issues that you could take credit for? Because those are something that you are more focused on, which is level 5 and above. So technically speaking, the other 50%, which is approximately the 7 plus 5, which is 12, should have been found earlier. So what does it tell you? Maybe the defect containment from a QA is probably not good. I mean, for a developer is not probably very good. So now you may want to tweak the process if you want, the practice if you want, so that these kind of issues you're not focusing on, and therefore you get an additional amount of capacity, which could be in terms of resource and time, that could help you focus on better bugs, right? And therefore help you to be much more effective in what you do. By a similar token, if I jump onto test cases, that means whatever, if I've got written ones, if I've got one-liner test cases, for example, or one-liner scenarios, for example, is it possible for me to analyze it rapidly to find out how is the quality of the test cases? So you might say, hey, if I've already done this review, why are you doing this again? Nothing. This is just another way of reviewing it. Think of it that way, right? Again, it's not just about number of test cases. It's really about the quality of test case, which I'm quite sure all of us appreciate. So what do we mean by quality? It is about how powerful are they? When I say powerful, does it have the power to find interesting issues that matter? Is it targeting the right areas? Is it clear and sharp and purposeful? Or is it very vague? So depending on who does it, for example, it might be very interpretation subjective, right? So that is what it's trying to find out. So if it is very potent, that means it has the power to uncover a hidden issue which is serious in the right area, and if it is sharp and clear, so that when I probably use it to evaluate, I have less ambiguity in terms of what I should do. When I say ambiguity, I'm not saying that you have to give a detailed procedure as in terms of additional sentences. It has to be really sharp in terms of conveying its intent very clearly as to what it is doing. So if I were to take it further and expand upon these 3 things that we talked about, potency, one part of the potency would be to say, do you know what issues you are targeting and based on the highest quality levels? Do you know what areas you're targeting? Are you targeting a building block or a structural component, which I call as SC? So that means if I'm going to test something, and if I'm trying to find out if the button is positioned properly, or if the API's value, the parameter is within bounds, those are all very basic level implementation related issues, right? So which means you're trying to target a building block error. Whereas if you put together a set of structural components and say, here is a feature as a square which consists of 4 of these little circles, it simply means I have a feature. So which means you're saying I've got an entity which is slightly bigger, and a composition of features will become a kind of a end user requirement, and a set of users may constitute a business flow. So what you're really saying is, okay, I have test cases, for example. Are you looking at finding issues where? Are you looking at is this scenario, for example, or case, for example, focused on finding an interesting problem or an issue, potential issue in the larger business flow? Or is it looking for some issue in the building block? That's what I mean by saying targeting what area. Thirdly, we know that sometimes the intent is to conform, sometimes the intent is to find out. It handles exceptions very well, and therefore it's robust. What we normally sometimes call as positive/negative test cases, right? That means basically saying the intent is to conform and to go non-conform, which means anything outside of conformance, to help you ensure it's robust. And finally, its purpose. Is it written well so that it's sharp and clear, or is it kind of vague? Right? So given this, remember we were talking about potency, which is a combination of quality level and an intent. The second one we talked about is the target, which is really about what entity are we actually testing really. And lastly, we talked about clarity, which is in terms of is the purpose that's written, it is very clear. So is that one-liner or two-liner that we've written, is it clearly and sharply communicating its intent? Right? It would be nice if it is. So now, as an example, I have taken about 37 odd test cases, which obviously you can't read because I just tried to fit one. But all I wanted to show you was I've categorized each one of them into 4 columns. The same 4 columns that I showed you before. Quality level, target area, that is entity, intent, which is positive and negative, purpose, which is clear or vague. That's what I've tried to put in this column. So I've categorized the test cases into target, levels, objective, and specificity. Objective here is positive or negative. Specificity is clear or vague. So that's what I've tried to do in these 4 columns. Now all I'm trying to do is to summarize them. So I now analyzed. I found that maybe there are no test cases related to basic validation issues, but there are about 15 of those test cases related to some, in this case, I think a lot of UI matters, which are related to the interface of UI. Approximately about 9 of them relate to basic functional behavioral issues, and about 13 of them relate to kind of end-to-end flow. Right? That's what this data seems to indicate. If I go further down and look at intent, target, area, and entity, this is how it's stratified. It seems to indicate there are about 26 of those test cases which seem to be conformance oriented, and the remaining 11, that is 37 minus 6, the 16, is about possibly non-conformance oriented, trying to go outside and trying to break the system. And by the same token, when you look at entity and you look at it from 4, by reading the scenario, I'm trying to infer and say, hey, about 15 of them, which is about 40%, the test cases or scenarios are primarily focused on validating only a structural component. Whereas about 13 of them, which is about 1/3, little over 1/3, is about user requirements. Right? But what do you want to do? If I were a QA person, probably I would expect to a larger degree that my 100% of test cases that I've written ideally focus on the higher order. That means more focus from a requirement as in terms of a customer using something and an end-to-end business flow, rather than look at early stage components or features, which I presume should be the focus of a person who is building the software, could be a developer. And then it said approximately about 92% of this stuff is apparently well written. So it's seemingly sharp and clear, and about 3 of them are not very clear. So if the picture was very lopsided, then you would probably ask, why is it so vague? Is it actually powerful? Right? That's what you would ask. So what we're trying to do is trying to look at the content of these test cases and get some indicative measures of potency, target, and specificity to help us improve or judge and improve the effectiveness of test cases and therefore the testing. So as the last maybe 5 minutes, maybe 4.5 minutes really, it's about a tool that we have developed recently, which uses a bit of an Gen AI stuff, which understands HIBIST, which we call as doSmartQA Intelligent Analyzer, which provides an insight into these two things that I talked about, defect containment efficiency and test potency, so that we can test effectively and hopefully slash out rework. That is the intent. So what I'm going to do is to just walk you through a small piece demo just to illustrate what it is. And the reason for me adding this tool is because that's exactly whatever that we've talked about in the last maybe 20-25 minutes is what this tool does. So whatever reports that I did kind of show you as examples are really from the particular tool here, which is available free. I will also share the link with you at the end of the slide and send you a message too. You're most welcome to try it, and of course send me the feedback if you have. So I will click here. Hope you're able to hear it.
No, sir, audio is not there.
Okay, one second. Let me. Okay, that's an issue. So I don't know how to adjust. So let me see if I can. To invoke the doSmartQA Intelligence Is it Analyzer, audible now? Type in Analyzer with a Z dot stacksoftware.net. Is it audible now? Colon 3000.
Yes, sir.
And press enter. So before we can do anything, enter your name and your email address and press continue. Now you have two things you can do. One, you can analyze test cases, you can analyze defects. So let's choose the analyze defects first. Once we do choose the analyze, you have to upload the file. So I have a set of sample defects in this sample defect CSV file. It can be a CSV or an Excel. Let me upload. And all I have to do now is to say, okay, it's got two columns. It's got description and levels. What I need is description. So let's choose description and then we hit analyze. So now it takes the description column data and intelligently handle it. So now you see the analysis is done. So if I scroll through what it contains, what it simply talks about, this just gives you a bit of an outline as a report as to what it did. It is kind of classifying the defects into levels. So it kind of gives you a quick outline what these levels are. And then tells you, look, you got these defects which have been categorized automatically into these quality levels, L1 to L9, as you can see here. So it says there are 4 defects in L1 quality level and 2 in level 2 and so on and so forth. It does very simple interpretation. It simply says there are approximately 9 defects. It's about 37.5% of defects, which are very basic, pertaining to level 1, 2, and 3. And about 7, which is about 29%, relating to the functionality and of at L4 level, and a composite functionality, which is like a flow at L5. And the remaining 8 are at higher order defects, which are related to L6, L7, and L8, which might be related to some attributes and deployment and migration and so on. So that's all it did, right? So now this gives you a bit of an insight into the quality of defects from which you can take on and analyze and understand and figure out, am I finding the right defects? If these defects were found by the system tester, why is it 37% of defects I am still finding which are related to earlier levels, and so on and so forth. So now that you're done with this, I hope you find the analysis useful. So I think I did. I'm going to say yes and email me the analysis report. And we are done. So now, having done this, I'm going to show you the second one. I'm going to again redo the same thing, which is entering my credentials so that you can send me the report. But now what I'm going to do is to analyze test cases. Again, it can take an Excel or CSV. So let's choose a CSV file of sample test cases. And what it needs is just needs a column which relates to the description which I think in the CSV is titled as scenarios. I choose the scenarios column in the CSV and hit Analyzer. So what do you see here? So it, of course, it gives you the description of what the levels are, but basically just try to classify test cases to what level they belong. So as you can see, there are about 11 of these test cases which belong to a level 2, and about 14 which are part of level 5, and so on and so forth. So out of the 35 test cases, the simple interpretation is 24 are positive, 11 are negative, 14 are clear, 21 are vague. With respect to quality levels, 11 of them, that's about 31%, are in L1 to L3, 24 are in L4 to L5, and like that. And by the way, it also does something interesting. It also kind of deciphers from the text as to what is the target area. That is the test case trying to find issues in a very basic building block like a component, or is it trying to find issues in a feature, or is it related to the larger context of a user requirement, or in a much larger context related to the business flow? So it basically does four simple analytics: intent, clarity, target area as integer granularity, and of course, quality levels. I hope you find this analysis useful. I did. So I want to get the report. You already typed in the name. Hit the email analysis report, and there you are. Check your email. Okay, I hope you had a quick glimpse of what the tool does, and whatever that I talked about as part of the Smart Analytics is what is available as part of this tool. Thank you so much.